Let's be honest, physics can feel, well, a little intimidating, right? It seems like this huge, complicated subject. But you know what? Just like any massive building, it's all built on a really solid foundation. And in this explainer, we're going to show you exactly how to lay that foundation so you can start building your own understanding of physics one piece at a time. So think about it like this. When you see a giant skyscraper, you don't start trying to figure out the penthouse suite first. No way. You have to understand what's happening down at the ground level. Physics is pretty much exactly the same. So the real question isn't, where do I start, but rather, what's holding this entire thing up? All right, so let's just run with this whole building idea. Imagine every concept in physics, motion, forces, electricity, all that good stuff, as a different floor in our skyscraper. The higher you go, the more complex and, yeah, the more advanced the ideas get. And what happens to a skyscraper if it has a shaky, weak foundation? You know the answer. The slightest pressure, the smallest problem, and the whole thing just comes crumbling down. Learning is the exact same. If you don't have a strong base, those more advanced topics are going to feel unstable, confusing, and you're just going to get stuck. So what is this rock-solid foundation for the entire building of physics? Well, it's mathematics. It's the concrete, the steel rebar. It's the very bedrock that every single physical law and theory is built on. This right here, it really gets to the core of it. The relationship between math and physics is direct, it's unavoidable. One of our sources put it perfectly. Math strong, physics strong. Math's weak, physics weak. It truly is that simple. So to build a strong physics foundation, we've got to master the right math tools. Okay, so let's open up that toolkit. Every single builder needs a reliable measuring tape, right? Well, for us, one of our most fundamental measuring tools is the distance formula. This is how we can precisely calculate the space between any 2 points. Put simply, if you've got the coordinates of 2 different points on a graph, this formula will give you the exact straight line distance between them. It's a core concept that you're going to use again and again and again. Now, don't let the formula itself scare you. At its heart, this is really just the Pythagorean theorem dressed up a little. You find the horizontal distance, that's just the difference in the x-coordinates. Then you find the vertical distance, the difference in the y-coordinates. You square both of those, add them up, and the square root of that sum gives you that direct line, that distance between the 2 points. Let's actually walk through a quick example. Say we want the distance from the point 2, 4 to 5, 7. First, we just plug those coordinates into the formula. For the x's, that's 5 minus 2, which is 3. For the y's, it's 7 minus 4, which is also 3. Easy enough? Next, we square both of those, giving us 9 and 9. Add them together, you get 18. So the final distance is simply the square root of 18. It's a clear, repeatable process every time. But, buildings aren't just straight lines. They are full of angles that give them strength and structure. And this brings us to our second essential tool, trigonometry. This is the part of math that lets us understand the super precise relationship between the angles and the side lengths of a triangle. Right at the heart of trigonometry, you've got these 3 core ratios, sine, cosine, and tangent. And they are incredibly powerful. Seriously, if you know just one angle and one side length of a right angle triangle, these little ratios let you figure out all the other sides and all the other angles. This is absolutely fundamental for everything, from calculating the path of a baseball to understanding the forces acting on a bridge. Mastering these is key. Now, in order to collaborate and build on the work of others, scientists all need to speak a universal language. And when it comes to angles, that language includes both degrees and radians. They're just 2 different ways of measuring the exact same thing, and you really need to be fluent in converting between them. And luckily, the conversion is actually super simple. To go from degrees to radians, all you do is multiply by pi over 180. To go the other way, from radians back to degrees, you just flip it. You multiply by 180 over pi. It's a clean, inverse relationship, which makes it pretty easy to remember. So there you have it. That's your starting toolkit for building your knowledge of physics. We've got the distance formula so you can measure precisely. We have trigonometric ratios so you can understand angles and direction. And we have angle conversions so you can speak that universal language of physics. With these tools, you are ready to lay the first floor. And look, this is just the ground floor. With this mathematical foundation firmly in place, you're no longer just an observer looking up at some complex building. No, you're the architect. You've got the tools in hand and you're ready to design. So the only question left is, what will you build next?